Thanks very much. It's a great pleasure to be here to tell you a little bit about the third centre of the four, actually. As you've heard, there is a fourth centre which you won't be hearing detail about today. So just some background, really. First of all, we're all very familiar with the challenges that the world's food system is confronted with. Very large population growth, growth in the middle class, changes in markets, climate change, issues of animal health, soil productivity on the declining everywhere, famine, malnutrition, and so on and so on. The issues that are identified here are all across the food system. So we have obesity at one end of the food system, we have soil health and productivity and animal health and productivity at the other end of the food system. And if we attempt to address any of those challenges that confront us in isolation and fail to recognize the connectivity that exists between those different aspects of the food system, then we risk solving one problem at the expense of solving another problem. So the risk of causing another problem. So the food system is interconnected, and what we want to do in Agrimetrics is essentially to build the connections that allow us to understand the food system in its entirety and to solve problems in one element of the food system without creating new challenges in the other elements of the food system. There are enormous opportunities that face us as a result of the explosion in the amount of data that's available to us. So there are a number of statistics that I like to explain this. One of them is that if we encoded all of human knowledge, God knows how we'd do that, if we encoded all of human knowledge, it would occupy about a third of the amount of data that is already in existence in the world. So that tells you lots of things. It tells you that there's an awful lot of data. It also tells you that there's an awful lot of duplication and noise in the data that is being stored already. Another statistic, 95% of the data that is in existence was created in the last 2 years. So the volume of data that is confronting us is growing at an enormous rate. And that means that we have to do things differently. We have to organize and capitalize on the opportunities that data creates, this increase in data, in a very different way from the ways in which we've been used to dealing with data in the past. And that applies to both industry and to academic scientists. So I'll take the non-controversial issue of scientists first of all, before trying to set out the challenges that confront people in this audience. So for scientists, historically, the way in which we've collected data has been predicated on the fact that data is very hard to come by, you're very unlikely to get very much of it, and you therefore need to concentrate on getting as higher quality data as you possibly can. And that's why people like Fisher spend a lot of time working out how you design very carefully controlled experiments, because the experiments are going to be costly and you're only going to get a small amount of data from those experiments. Now we're confronted with huge volumes of data. We don't need to worry about the costs of getting hold of that data. It's just appearing for free wherever we look. But the difficulty with that is that that data is now very, very noisy. It is not the high quality data that we're used to seeing as scientists. But we are now in a position where instead of looking at a sample of data, we're increasingly able to look at the whole population. And so when we do statistics and when we try to analyze the data, the ways in which we approach it are completely different from the ways in which we've approached it historically. We have to think about how do we make inferences on the basis of noisy data, and we have to forget about the fact that we were looking at a sample and we're now looking at the population. So scientists have to do things completely differently. Industry also has to do things completely differently, because historically, data in and of itself has been an asset that companies within industry have guarded extremely carefully. that asset is no longer an asset to the business in the way that it used to be. And the reason why that's the case is because the insights that you're getting from your private data that you're holding, protecting within your company, can now be obtained quite easily with another set of data that is available somewhere else outside your company. So that value of that data to you is now rapidly diminishing. And it's a simple supply and demand situation where the supply of data massively increases and the price falls as a result of that. So what do you do as a business? You start to change your focus so that instead of the value being in the data itself, the value is in the assets, in the insights that you get from the data that you hold. And that means if you want to get good insights from your data, the chances are that you will get better insights if you have access to other people's data in getting those insights. And that is true whichever company you're in. So data sharing becomes the name of the game. Now that is a huge mindset change, and not everybody is ready to make that mindset change. But believe me, the people that are making that mindset change already are the people that are starting to make progress and to start making that transition to being an data asset holder to being an insight developer. So the people that need to be ahead of the game are those that change their mindset and start to move in that direction and are moving in that direction already. So what's the role of Agrimetrics in this landscape? What we're attempting to do is to catalyze the creation of what we're terming a federated data ecosystem. So we acknowledge and know that lots of companies hold a lot of data and protect that data and are struggling with this transition from being data asset holders to insight developers. So what we want to do is to create the plumbing that sits at the heart of a data ecosystem so that different companies, a company who wants to be able to expose their data to other company data to create new insights, can easily come and plug their data into the ecosystem, and in that ecosystem gain access to other companies' data so that they can start to develop those insights. I'm not talking about an open data ecosystem. I'm talking about a data ecosystem that still protects the intellectual property that those companies are starting to develop as a result of those the new data that they're able to access. So this is not an open data system. This still remains closed data, but it will incorporate open data. A lot of data, notably government data in the form of DEFRA data, is being made open data. But those of you that have looked at that data will know it might be open, but it's not very easy to use at the moment. So that data also becomes part of the ecosystem that we're creating. And what will happen is that if you expose your data into the ecosystem, you will find it very easy to also to ingest the DEFRA data, which we're currently working on making more accessible to you. And again, I emphasize, when I talk about exposing data, I'm not talking about exposing your data in an open way. I'm talking about exposing it in a way that you plug it into the data ecosystem so that you can gain access in a way which is acceptable to you to other people's data. Just a word or two about the technology that lies at the heart of what we're doing. We're using what's referred to as the Semantic Web as the basis for creating this data ecosystem. I'm not going to get into the details of the technology, but I want to just illustrate why it's worth, why we're doing something, how this enables what I've just described. The Semantic Web is a natural evolution of the World Wide Web, which we're all familiar with. And the key innovation in the World Wide Web was it created an ecosystem of information, just like the ecosystem that we're attempting to create. And the innovation was that it allowed people to link directly from one web page to another using a URL or a URI, as they're now referred to. So those links created this web of information that we all use on a day-to-day basis now. Just the simple fact that we create a link from one web page to another. And then built on top of that is search technologies, Google just being just one of those technologies, that allows people to access and find information in that complex web of data, web of web pages, using a very straightforward interface. And very importantly, when Google sat down and decided that they were going to create that search technology, they didn't know exactly what the structure of the World Wide Web was going to be. They knew how it was going to be structured, but they didn't know that there was going to be a web page available on a computer in Boston that was going to tell you information about one thing, and a web page on a computer in Sydney which was going to have some information that was relevant to that page that's in Boston. They had no idea what the architecture of that web was going to be. They simply knew that it was going to be structured along the lines that I've described, based on links between web pages. What the Semantic Web does is it goes one level below that. And so instead of having web pages that are linked to one another, we now link the data within each of the web pages that we've got. So the web page now stops being a page that you're browsing, and it starts to become a sheet in an Excel spreadsheet or a sheet in a database. That's an analogy. It isn't literally one of those things. And so each data point within that sheet is now given a URI, and so one of those sheets could be a list of names of people that are in this room today, and then there's another sheet that is the list of addresses of everybody in this room, or a much longer list of addresses. The names are given a URI, and the addresses are given a URI, and then in just the same way as we link web page to web page, we now link name to address by providing the link between those URIs. So we can take an approach to data which is much less structured than the kinds of approaches which we're familiar with. We don't have to structure things in SQL databases and understand the way in which we want to query the data before we build those databases. We don't put them in Excel spreadsheets. We now just provide lists of data, attach URIs, and then structure the data by building links between the different data points according to the relationships that we're interested in. And that's the technology that we are building at the heart of our data ecosystem. We want to make it easy for data sets to slot into this semantic web, and thereby to access data sets that are elsewhere in the ecosystem. Enabling this is hard. We're not pretending that what we're trying to do is easy. So I wanted to just highlight one or two of the challenges that face us. Clearly, security is one. I've described this as a closed data ecosystem, which exposes data potentially to open data. So we need to have a comprehensive credential management within our system, and we also need to be able to create compartmentalized workspaces in that data ecosystem, so that if Sainsbury's are going to share their data with Tesco, I wish, then they need to be clear that they have a workspace within which those two data sets can be worked upon. This is a commercial offering, so we have the challenge of maintaining service in this space. At the heart of developing the data ecosystem is the development of vocabularies and ontologies. And essentially what this says is that we need to have ways of describing the world that we've got the data on. So in North America, they use maize to refer to corn, and here we use corn to refer to corn. Was it the other way around? Anyway, two words meaning the same thing. And that sort of issue arises everywhere. So we need to have comprehensive vocabularies that describe those ambiguities, and then we have ontologies that describe the relationships between different aspects. There's data licensing issues that need to be negotiated, and then we also need to work out what the business model is, so that where people are providing data to us commercially, they can be remunerated at the same time as we're remunerated for the IP that we develop in putting our platform together. So there are some really big challenges. We acknowledge those challenges, we're working on them, but critically, I think it's important to acknowledge that these challenges in the new world are pre-competitive in the sense that if Agrimetrics can focus its attention on some of these things, it saves everybody else running around trying to do these things in a piecemeal way. So that's our aspiration, is to catalyze the industry to make better use of its data by linking it and by tackling the pre-competitive challenges that are associated with that. And then it opens up the rewards for everybody in the industry to capitalize on our activities. Just to show you that we are a bit more than just concept, this is a diagram. I'm not expecting you to read it, but it does show you that we've spent quite a lot of time thinking about how we build a technical infrastructure, a technical architecture that supports what we're doing. But to make things just a little bit more tangible, I thought that I would just finish up by giving you an illustration, unfortunately from the arable sector, of something that we've done relatively recently. This is an application that we've developed which is aimed at supporting arable farmers, but it has the ulterior motive, if you like, of trying to demonstrate to arable farmers what the benefits of data sharing are. So possibly the toughest nut to crack in terms of encouraging industry to share data with one another is the farming community. Farmers are notoriously private about the data that they hold. So if we're true to our convictions and believe that data sharing is the way forward, we've decided that we're going to try early on to begin cracking that tough challenge. So what I want to emphasize here is that in what I describe now is the development of an application. We are not application developers in Agrimetrics. The application that I'm going to describe does two things for us. It enables us to do what I've just set out, which is to try to encourage farmers and demonstrate the benefits of data sharing. But it also demonstrates for audiences such as yourselves what is possible when we've built our data platform. So behind this application, which I will describe in a minute, I promise, is the linked data platform that I've been talking about up to now. So we have a soil data set, we have weather data sets, and we have data from the AHDB recommended lists, so some agronomy data sets that are in our data platform. Now, those three data sets, one comes from the Met Office, one comes from an organization called Soil Grids, and then the other comes from AHDB. And when you get those data sets, they come in a variety of different forms, and you can't immediately query those data sets as one. So we've ingested those data sets into the platform. We don't necessarily have to ingest every data set into our platform. All that we need to be able to do is to access them. We've built a data model that allows those data sets to talk to one another, and then we've built the app on the top of what we've created. So what the app does is it asks the farmer a simple question. It asks him to tell us, or her to tell us, what variety of crop did you sow, and where did you sow it? And then we then take that information and we use the location data, the location that they've told us, to look up in our database to find the weather conditions and the soil type that's at that location. We then throw away the location, so we anonymize the observation immediately and store in a database the yield, the variety, and the environmental conditions as reflected by the soil type and the weather at that location. With that data, we build up a data set of those sorts of observations, and then we then transfer that, use that data set that we've built up to look up all of the other sites that are in the database that have got similar environmental conditions and calculate the average yield of the variety that farmer sowed at those locations. And we feed that information back to the farmer as a comparison. So it's a benchmark of their performance. An enhanced yield, an enhanced variety selection tool for the for the farmer, if you like. And what that illustrates, the reason why we've developed it in that way, is first of all, it's a very simple application. We're only asking for a very simple data set from the farmer. We're not asking for detailed data on the agronomy of the crop, or on the costs and the prices of the inputs that they used, or on the value of the crop when it was sold. We're simply asking for a relatively unchallenged piece of information. And then importantly, what we do is we give back to the farmer as a result of that. Instantly, we give them back an insight that they wouldn't otherwise be able to have unless they accessed our data platform. Hence the encouragement to share data with us and with other farmers. Okay, so that's what we're about. That's where we're at. My colleague David Flanders, the CEO, is in the front row here. He's going to take a position on the panel in a moment, and he's going to deal with all the difficult questions. So thank you very much for your attention, and I hope I've shed some light on what we're up to.